Alright, we are officially live.
Sorry. I now have. Okay.
Nice.
Okay, so we need to look up information about histograms. Is that weird?
That's part of it. I also looked through the prep questions just briefly, and they are very good. If we could go through those, at least some of those, it'd be really helpful. They're good questions.
Okay. Are the prep questions different than the review questions?
What do you mean by prep questions? Like the...
Like the quiz, the group quiz is different than the review. Is that what you mean?
Yeah. No, I'm good. I'm good with either talking about it or just like trying to take the group quiz to begin with, or I'm good however we want to do it.
I'd like to go over at least a few of the review questions in the Lesson 8 before doing the group meeting quiz. If that's okay.
That's totally fine.
Sweet.
Why don't we start with, just give us a number of what you would like to talk about, Dustin, if you will.
Oh.
And we can each do that, or we can go through the whole thing. Let's take one by one.
Does anybody remember what's the difference between a parameter and a statistic? Let's get that out of the way.
I don't.
No, but I saw that one.
A parameter is a true but usually unknown number that describes a population. A statistic is an estimate of a parameter obtained from a sample.
Give the definition of parameter again.
So if you're on lesson 8 and it's the part 2 lesson summaries, this is in the lesson 3 recap. A parameter is a true but usually unknown number that describes a population. And then a statistic is an estimate of a parameter obtained from a sample. So the parameter is the truth. We usually don't know the parameters. But a statistic is the data we got that we use to estimate the parameter.
Okay. Okay. That makes sense.
Okay, so the random sampling, okay. What is a stratified sampling again? I don't remember that one.
So stratified sampling is when you have several groups, like you divide them by age groups, 12 to 16, 17 to 21, 23 to 24, and you take a simple random sample from each of those groups.
Okay. Then what was
So then
the
what is a cluster sampling?
Yeah, because that's how I would think of it, is like putting it into groups.
Here's what it says. A cluster sample is all items in one or more randomly selected cluster or blocks. So, let's pretend that you want data on the average test scores for a school, for schools in a certain state. Instead of getting all the test scores from all schools in the state, you'd get all the test scores from random schools through the day. So it's like taking a simple random sample of groups within a system. Does that make sense?
Yeah.
Where
the
stratified
in that you're getting individual group and then taking one of each of the group. But cluster, you're taking all from one and the same group.
Yes. Like a cluster, what's random is which groups. But in the stratified, what's random is the individuals within groups. Does that make sense?
Mm-hmm.
All right. Something that I saw in the recap that I think is worth noting are the 3 rules of probability.
Oh, yeah, we definitely need those.
So that's the lesson 4 recap. These are good. Lesson 8 is good stuff. I should have read this a long time ago. I like it. But so 3 rules of probability. A probability is a number between 0 and 1. If you list all possible outcomes, the probability of all these outcomes together is 1. Or, in other words, the sum of the probabilities is always 1. And the probability that an outcome will not occur is 1 minus the probability that it will.
Oh, yeah, that's right.
Alright, that was good. I'm glad I read that one.
What you're reading.
See what?
You're sounding really. Whatever you're reading, you're sounding really smart. Where are you getting it from?
Okay, so I'm on lesson 8.
Okay.
Part 2 says lesson summaries. And it says click on the link at the right. And you click on that link. Did you find it?
You in? Okay, so
Did everybody find it?
no, that's okay. Go ahead.
Okay. Okay. Does anybody else have any questions or things that they wanted to go over?
So I just read over the review questions, but what is the is it called the theory of large numbers? Large number theory?
Okay, so let's go over central limit and law of large numbers then. Law of large numbers means that the more samples you have, the closer your sample mean will come to the population mean. Does that make sense?
So the more numbers you have, okay, yep.
And the central limit theorem states that the larger your sample sizes, the tighter and more normal the distribution of sample means. Does that make sense?
That's the central limit theorem.
Central limit theorem. So law of large numbers is about getting closer to the population mean. And the central limit theorem is talking about about the normality of the sample means. Does that make sense?
Mm-hmm.
How do we assess normality using a QQ plot? What's a QQ plot?
That's a great question.
Don't even remember what it said. It's missing 5.
QQ plot, where are you?
Oh, I finally found what you were looking at.
Okay.
I have really slow internet here.
I know there's at least one example because
So Google says QQ plot is a plot of the quantities two distributions against each other, or a plot based on the estimates of quantiles. Oh, is that
Okay.
like the first quartile, the second quartile, third, fourth?
I don't think so. It's in lesson 5, and it says a QQ plot is used to assess whether or not a set of data is normally distributed. I'm going to look for it. I want lesson 5.
Okay. I have it pulled up. It says a QQ plot is a graph that is used to assess if data are normally distributed. If the points in the QQ plot are essentially in a straight line, then we conclude that the data are normally distributed.
Oh, I feel like I remember that. But I'm going to look it up because I wish to be more confident than that.
And then it goes on to say in a
No, I'd like to be
QQ
more
plot.
confident with the test.
Yeah. So it says in a QQ plot, the z-scores for the observed values in the data set are plotted on the horizontal axis. The z-scores of the expected values, assuming the data are normally distributed, are plotted on the vertical axis. And so, if the data follow a normal distribution, then we would expect these points to lie in a straight line.
Gotcha.
If the data are non-normal, we expect to see a distinct curve, a QQ plot.
I see what it's saying. And so this is saying that you have data, and you have you have a prediction of what the numbers would look like if they followed a normal distribution.
Mm-hmm.
And so the expected is on the vertical, and the observed is on the horizontal. So if they line up perfectly, they would all end up in a line because they would all be equal to what would be 1. So just
They would all be in a line, like straight up and down.
no, they'd be at a 45-degree angle, basically.
Yeah.
Oh, okay, great.
Like just split in the middle of that graph. If the graph is a square. But I understand. That makes total sense. Do. All right. Does anybody else have any questions?
What about the properties of a normal density curve?
I'm sorry, what was that?
State the properties of a normal density curve.
Okay. Well, there's the 68, 95, 99.7 rule that almost all normal curves will follow. Well, that says that within within a z-score of 1, within a standard deviation of 1, 68% of all possible outcomes will be within that. Within 2 standard deviations, 95% of the data will be included. And within 3 standard deviations, 99.7% of the population of the sample would be included, if it's normal.
So a normal density curve is systematic and bell-shaped.
Right.
The curve lies above the horizontal axis. Total area under the curve is equal to 1. I'm a good reader, sorry.
Yep. Standard normal distribution is probably what also we want to look at for there. Oh yeah, that's what I said. Just kidding. But good question, Ricardo. Let me.
I feel like the things I'm going to forget are the ones that we studied the second week. I feel like I need to go back over those.
So like lessons 3 and 4.
I don't think they're very hard.
What am I doing? I was in the bathtub. Oh. You watch it.
That's my brother.
Nice.
They can hear you.
What's up?
Oh my God.
What's up, dude?
They can't see you. No. Don't get dressed.
You want to see my muscles?
No. That's my brother, everyone.
Histograms. Bum, 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 ba-dum, bum, ba-dum, bum.
So do you think we'll have to make a histogram for our test? I hope not.
We
I've
might.
never... Oh man.
We should try.
I don't remember histogram. That's my problem. Alright, other than history, I feel pretty good at everything. I don't know if it's the reason I'm okay with it.
Okay, what?
Hello?
I'm still here. Here.
Okay. I am. My sound cut out randomly, and I was worried.
So when are we supposed to take the exam?
Tomorrow.
Or so we have to submit everything by tomorrow?
Uh-huh.
I think so.
Okay.
Insert histogram. Where is histogram? That one. Okay. I figured it out. I'm satisfied.
Group 3, I think.
Does anybody not know how to make a histogram?
I don't.
Okay. So, if you go in
I
Excel.
don't remember.
So I just did it, and I don't know how to do things, so I know you guys can do it. So, if you're in Excel, in a column, a vertical column, you input all the data points you want. So what I did, I just used, in lesson 3, it just gave you 10 Dr. Bills of 10 tuberculosis patients in India. So I took those numbers, and that's what I made my histogram out of. So you input all your data points in a column. You highlight that column, and if you're using the same version of Excel that I have, it is, you go to Insert, Charts. In the bottom row of charts, in the box of charts, in the bottom right corner, there's a little box thing with an arrow. You click that, it goes to See All Charts, and then you can pick exactly which chart you want. And it'll automatically use the data points and distribute them evenly. Does that make sense?
Yeah, I got it.
And mine turned out looking exactly like the chart in lesson 3, which made me feel a lot better.
So was it like, okay, the insert, it wouldn't be the quick analysis thing button, right?
It would not.
Okay, so insert.
Do you see a thing saying charts?
You want to insert, and then
Charts,
you
yes.
Okay,
hit the
let me
little
try to screen share,
arrow.
even though this never works. Can you guys see my
Yes.
Excel? Yes.
Mhm.
Okay, so this is where you usually start, up here at home.
Mm-hmm.
If you go over here to Insert,
Mm-hmm.
over here to Charts, there's a little box over here, and it'll come in. I went with clustered columns, and it'll preview what it looks like with your data. Click on one of those, hit OK. Done.
That's all.
That's all. Done.
Nice. All right.
I believe that we can do that.
Yeah, that's
Because
easy.
that was easy. Sweet. How do I find the 5-number summary, the mean, and the standard deviation in Excel?
Um,
How do you find the standard deviation in Excel?
The mean, the standard deviation, and the 5-number summary.
Oh, I think you equals mean,
Uh-huh.
and then is equals STDB,
Okay.
and same with median. But are you talking about doing the formula in Excel?
Yeah.
it's like a function, so you can like.
Yeah, I have all my formulas set up in Excel, and that way I just have to type, numbers, and that way I can get all my answers. But
Okay.
it's not that hard. Yeah, it's super simple.
I'm not sure if it's the same for the 5-number summary though. Because I can do.
They gave us a program that we could type stuff into. I'm not sure that
Which lesson was that in? I remember. Oh wait, I remember. I see it. Oh. Oh.
Do we have any more questions?
I do not.
Should we start on the quiz then?
Let's do it.
it's not good.
Everybody ready?
Yeah.
Wait, how do I get there? Okay. Group meeting quiz. Do, 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 do. Why does it have 1 attempt in progress? I never started this.
You're on you and not me, right? Because I just started it.
I'm on. Oh, dang it. That's confusing. Log out. I don't
Sorry, I
need
was doing
this.
homework on the computer.
Why would you even do that?
And because the
Give me a second. I gotta log into everything again.
You're fine.
Hello.
Hi.
Sorry, sister just walked in the room.
Oh, I thought you were just doing sound back there. I'll have to do your homework for you.
Jenna, I took my shoes off and my feet smell really bad.
We all heard that.
Oh, dang it. All right, are we ready to start?
Yes.
Yeah, we're ready.
Okay. So, question 1. We are doing this with the group.
Mhm.
Check.
I got that one.
Oh, these are just the review
Okay,
questions, I think.
Which of the following variables are categorical? Pink is the brand of toothpaste. Convenience store.
Yeah, you are correct.
I can't hear you very well.
She said the randomly selected brand of toothpaste at a convenience store is categorical, and that is correct.
Okay. For question 3, the mean IQ test score in the United States is 100. 20 randomly selected statistics students took an IQ test and the mean of their scores was 112. Which of the following statements is/are true?
100 is describing the population, and so that one's the parameter. 112 is the estimation based on the sample, so that one is the statistic. Rotham City has 4 distinct neighborhoods. The property values are very similar within each neighborhood, but that vary considerably from neighborhood to neighborhood. One neighborhood has very low property values, and another has extremely high property values. Property taxes are usually roughly proportional to property values. What type of sample should we collect to gauge the residents' responses to a proposed increase in property taxes? I said a stratified sample.
Okay, 5. When design experiments are conducted in a public school systems, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students in that district. The experiment is then conducted using all the students in the selected classes. Which type of sampling scheme is implemented?
Would that one be a cluster or a systematic?
Cluster.
Stratify a cluster.
Cluster sample is all items in one or more randomly selected clusters or blocks. It's not systematic. I think it's cluster.
I agree.
So which one is going to be for 5?
Cluster. The last one.
Cluster.
Okay, so question 6. At a school fundraiser, the name of every person who attends was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented? A simple random sample?
I said simple random sample.
Yeah.
Yeah, I agree. Okay. A special interest group is conducting a survey regarding wolves in Yellowstone National Park. To adequately gauge opinions on both sides of the political spectrum, the researchers took a list of registered Democrats and selected a simple random sample of 100 people. Then they took a list of registered Republicans and selected a simple random sample of 100 people. Which type of sampling scheme was implemented? This is a trick question.
I think it's stratified random sample.
Stratified.
Because they're dividing the data into groups and taking a random sample from each group.
Sorry, you were cutting out a little bit. I couldn't hear what you were saying.
I'm sorry. I'm at the church and it doesn't have great internet. I think it's stratified random sample because they broke them each into groups and then took a sample from each of those groups.
Okay. Okay.
Okay, so now we have to open a file, right? Okay, that means says calculate the mean of the amount spent. So equals average. Oh, that's weird, it's not working. I can do anything in that file.
Well, we know this from the beginning of the semester. Hope it's in there. Hold up there. Is it called crossroads purchases?
Yeah.
Okay. All right. It was in the. There's a whole bunch of stuff, data tables that they gave us at the beginning of the semester. So, what is the question?
I don't know why I can't do anything. What the heck?
Calculate the mean of the amount spent.
So what we have to do, I think, is we have to do equals average, and we have to take all the amounts from credit, well, A2 to B2 to B86. So that's going to mean. So to take it, go down. So it's going to be 4.76, or 3 decimals, 4.755.
I got 4.771.
Hold on, I'm almost there.
I got 4.771.
Let's try again, let's see.
I got 4.771.
Let's see. Okay, yeah, I have 4.771059, yeah. So yeah, that's going to be 771.
Calculate the standard deviation.
So for the standard deviation, it's going to be equals STD EB, so parentheses, and we take the same amount, all the same numbers. So that's going to be 1.911. Well, 912 rounding. Let's see. Yeah, 1.912.
Okay.
Okay.
I got 1.9112.
Yeah.
I got
Is that what you got?
1.912. I got
Yeah.
1.912 because we're rounding to the third.
Yeah.
Yeah, right. See, I think we need that. I don't remember what the program was that they gave us. Is that in?
Oh yeah, I think that's in the second week.
No.
So then we have to create okay, we have to create one.
Histogram.
Yeah.
We just do it with one of the charts on here, or do we have to have that?
Well, I did the insert with thing, and it's a line graph, so I don't know if it has to be like the box graph.
Let's see.
You know what I'm talking about?
Yeah, I do. I think the line graph is good.
Mm. I don't know if I'm doing this right.
I really think we could find that program that we had. When did we do histograms? Was that the second week?
Yeah, that was lesson 3.
So do we have to highlight everything that is in amount and insert the chart or the graph?
What?
So what do we have to do in 10? Do we have to highlight everything that is in amount?
Yes.
And then go to insert and do the graph?
Yes.
Okay, so I think I did it.
Come on, internet, help me out. Alright, and it did a thing. Oh no.
What?
I'm trying to figure out what variance is. Where did it? I know it dot. Variance is the square of the standard deviation. Okay, got it. Figured it out.
Did you go on to the next?
Yeah. I was looking at question 13. And the answer is variance.
So are we working in 11 and 12 right now, and 13?
That's where I'm at. I might have skipped a little bit ahead.
Okay, so for that chart, is the mean 38.075?
That's what I got.
That's what I got.
So, okay, so are we supposed to use that number, or we have to round that?
That's the number I used. So for question 11, I got negative 0.165.
Okay, so let's see.
That's what I got as well.
Okay, one sec.
And then for 12, I got 0.672.
Okay, one sec. Okay, so 11 was minus 0.165, right?
Right.
Okay, and okay. Okay, and 12 is 0.681.
Okay, is 15 false? The standard deviation can be negative.
I said it was false.
Okay.
For 14, did everybody get 0.619?
I got 0.715. I just put it into Excel. I didn't use.
Okay, well, so did I.
So is that,
Which formula did you use?
is that 14?
Yeah.
So 0.715, right? Yeah.
That's what I
Yeah,
got. But
the formula is going to be equals S T D E V, and then you just highlight the numbers.
hmm.
So try that in Excel.
Okay, now I got 0.715.
Okay.
Okay, so is 12 0.681?
For 12, I got 0.672.
hmm
I did too.
So it's
Awesome.
so why have a different answer? Okay, so X is going to be 38. No, X is going to be 37.25 minus 38.075. That's weird.
Well, I actually have to get going because my brother has seminary graduation pretty
Okay.
soon. So, thank you
Awesome.
guys for being flexible and meeting today instead of yesterday.
No problem.
I do appreciate it.
No problem. I only have about 15 more minutes myself, so
Me too.
I don't think
So,
we're
glad
gonna
we
make it
reached
all
this
the way through the
consensus.
quiz. So we'll get as far as we can go.
All right. So because of the test, we're not meeting tomorrow, correct? I'm just assuming.
That's what I thought.
I
Okay.
Yeah.
think that's a good plan.
Okay. Well, awesome. Thank you
All right.
guys again.
Yeah.
All right. Bye.
You guys have a good night. I'll see you later.
You too.
Okay.
All right. 16. Which location resulted in the most consistent temperatures?
I can hear you.
So, gotta be what's right in the middle, so it'd be average. Equals clear. Alright, so I think we're pretty much at the point where we're just gonna finish up on our own. Is that true?
Yes, because I've got to. My son
Yeah.
is about done with Young Men's, and I need to take him home.
I also need to go, so I guess that's it. Thank you guys for doing this tonight. This was very helpful, actually. So, thanks.
Yep. Thanks. Bye.